Good day, SMAW learners. Welcome to Industrial Arts TVL SMAW video lesson on Weld Carbon Steel Plates in Flat Fillet Position 1F. I am Giovanni Poch and Peña Flor, your TVL SMAW teacher from Lawakan National High School, Senior High School Department. Weld Carbon Steel Plates in Flat Fillet Position 1F. Content Standard. The learner demonstrates understanding of basic concepts and underlying theories in welding carbon steel plates in flat fillet position 1F. Performance standard. The learner independently demonstrates competency in welding carbon steel plates in flat fillet position 1F based on acceptable welding standards. A few reminders. This supplemental video lesson is best used with your SMAW Quarter 3 printed modules, a pen and a piece of paper, and a study area that is suitable for your learning activities. Objectives. At the end of the lesson, the learner will be able to define fillet welds, identify the types of fillet joints, determine the acceptable and unacceptable weld profiles, perform fillet weld on carbon mild steel plates in flat position 1F, following the OSH standards. Let's have a quick review of the previous lesson.
A type of tack that uses stiffeners to keep both base metals aligned is called semi-permanent tack, permanent tack, bridge tack. None of these.
The correct answer is
the kind of tack welding that is done in a very short bead to fit up welds temporarily. None of these. Permanent tack, semi-permanent tack, bridge tack.
The correct answer is
the kind of tack welding that measures at about 1/4 to 1/2 length and is used to fit up heavy pieces of metal. None of these. Permanent tack, semi-permanent tack, bridge tack.
the correct answer is
What should the plates be checked for after tack welding? Correct root gap, distortion, all of these, angular plate alignment.
the correct answer is
Where do we place the tack in tack welding? In one side of the plate, in the middle and on both edges of the base plate, in the middle of the edges of the base plate. None of these.
answer is well done, small learners. Before we start with the lesson, let's have a short activity. It's called 4 picks in 1 word. Kindly unscramble the letters to form the word. Correct. It's fillet. Or others would say fillet. Uh, I've done a little research on this word now. If you talk about the word with 2 L's, the pronunciation becomes fillet. Now, if the word is spelled with 1 L, it is pronounced as filet, coming from the French word like filet mignon. Just a little bit of English trivia. Fillet welds. Fillet welds are some of the most widely used joints in the welding field. Since fillet welds are used so frequently, there are several factors that you should consider before fabricating such weld. The skills you develop in welding can lead you to countless opportunities in a variety of industries to a more lucrative and rewarding careers. Are you ready to take your first step? Fillet welding refers to the process of joining 2 pieces of metal together when they are perpendicular or at an angle. A fillet weld is a weld type in the cross-sectional shape of a triangle. It is the most popular and most commonly used weld in the industry. There are 3 types of fillet joints. Talk about lap joint. Lap joint is frequently used in all kinds of work, which may be single fillet lap joint or double fillet lap joint. Single fillet lap joint should not be used if root of joint is to be subjected to bending. This type of joint should never replace the butt joint on works under severe load. The second is the corner joint. The corner joint is a weld joint formed when 2 joint members are positioned at approximately 90-degree angle with the weld joint at the outside of the joint members. No preparation is needed and fit-up is usually simple. The third one is the T-joint. T-joint is a welding joint at the junction of 2 parts located approximately at right angles to each other in a form of a T. In terms of welding, thicker metals at the edge to be joined should be beveled. No preparation of edges is necessary for thinner plates, and fit-up can be fast and economical. Now let's talk about the parts of a fillet weld. Okay. The weld root is the area where the filler metal intersects the base metal opposite the face, while the weld face is the exposed surface of a weld, bounded by the weld toes of the side of which welding was done. The weld face of a fillet weld may be concave or convex. Weld toe. So here we have 2 toes. No? The weld toe is the intersection of the base metal and the weld face. So as you can see, there are two intersections. No? It is the point at which the weld face meets the base metal. Weld leg. The weld leg is the distance from the joint root to the weld toe. The joint root is the part of a joint to be welded where the members are closest to each other. The actual throat. Is the shortest distance from the face of a fillet weld to the weld root after welding. So from this distance here to there, that is your actual throat. The effective throat is the shortest distance from the face of a fillet weld to the root weld minus any convexity after welding. So it just forms the shape of a triangle, a right triangle if I'm not mistaken. The theoretical throat is the distance from the face of a fillet weld to the weld root. So from this area up to here. So that is your theoretical throat. Let's talk about the heat affected zones. Okay. The heat affected zones is the portion of the base metal which has not been fused or welded but has been metallurgically affected by the heat of the welding. So the intense heat of the welding affects the property of the metal, even though if it's not melted or fused, no, by the weld itself. So it is metallurgically affected. The joint root. The joint root is the location where you want to weld the base metals together. So this is one metal, and then this is another metal. Okay, so this is joint root number 1. Now, if you're going to weld on this side, this is your joint root for this side. Now, if you were going to weld on the other side, this is the joint root for the other side. Acceptable weld profile. The profile of a completed weld could have considerable effect for the performance of the weld operation. It is the welding inspector's function to distinguish these discontinuities by way of visual inspection and quite often to evaluate the acceptance or negativity. So when we perform welding, we don't just weld, no? So there are a couple of considerations, no, to make an acceptable weld, no. So the term being used is not really a good and a bad weld, but it is more of an acceptable and a unacceptable weld profile. So here are some the figure shows the desirable or acceptable profiles, no? So the size of the weld, no? There are corresponding desirable sizes for these types of weld. At the same time, when we talk about convexity, no, Convexity C of a weld or individual surface bead with dimension W shall not exceed the values of the following table. So, a certain type of width of weld will only have a certain convexity allowed. Oh. Again, just being discussed in this table, the width of the weld face or individual surface bead W, if your width of weld face is less than or equal to 5/16 of an inch or 8 mm, you're only allowed a maximum convexity of 1.6 mm. So the thickness of your convexity, no, sa Tagalog, yung umbok ng iyong weld, no, should not exceed 1.6 mm. Okay? Okay, so if the width of weld face is greater than 5/16 of an inch to less than 1 inch or 25 mm, your maximum convexity C will be 3 mm. So it is directly proportional to the width of your weld. So in width of weld face greater than 1 inch, the maximum convexity is 3/16 of an inch or around 5 mm. As I've said earlier, so the bigger the width of weld face, the bigger also your convexity. Unacceptable weld profiles. Unacceptable weld profiles can cause problems associated with a reduction in base material thickness, effective weld size. It can provide stress concentrations on the weld or plate surface, effective weld size. The illustration shows weld discontinuities that can often seriously detract from the overall performance of a welded component in service. The welding inspector is often required to determine the extent of these discontinuities and to establish their acceptance or rejection based on the relevant acceptable criteria. Now, it was mentioned that a welding inspector is the person who will do or determine these unacceptable weld profiles. But a good SMAW welder or SMAW learner would easily identify, should develop the trait or the skill to identify whether his weld is acceptable or unacceptable. So here are some basic examples of unacceptable weld profiles. Insufficient throat. So as we discussed earlier in the parts of a fillet weld and anatomy, so we have a throat, no? So this part here up to there, that is your effective throat. So this unacceptable weld profile has an insufficient throat. So ibig sabihin, kulang. Okay? So ano man kakulangan ay hindi maganda pagdating sa welding. Next is excessive convexity. Yan, okay? So dito sa part na to, yan, as we've said, no, yung part na yon is nakulangan siya. So hindi nagkaroon ng weld dun sa part na yon. So kung medyo kulang yung weld natin, that would entail, no, a reduction in the strength of the weld materials, or sa Tagalog yung kapit ng weld mo, no. So there are possibilities. There could be possibilities, no, that pwedeng matanggal or bumitaw yung weld mo. So in this case, there is an excessive convexity. So medyo malalim yung part na yun doon, no. So there is hindi siya accepted convexity or dito sa part na to. So it falls below the maximum, or it falls below the minimum, no. Okay. Next is excessive undercut. So undercut yung area na to, no. One way of causing that weld is masyadong mabilis yung transition ng weld or ng electrode, no. So yung part na yon is parang nagkakaroon ng kanal, so humuhukay. So in that case, that is another way, no, or it could be a cause of welding failure. Ayun, kagaya nga ng nabanggit ko kanina, pwedeng matanggal or mabali, lalo na tong part na to, yung dinugtong mo na to na weld metal. Okay? Overlap. Yan. Ito naman, this is an unacceptable weld profile because sobra siya. So, hindi rin advisable sa isang weld na sumusobra yung welding mo. So, dapat tama lang, no? So, yung case na to, ayun, yung part na yon, sobra siya. Now, when we talk about insufficient leg, yan. So, more or less insufficient leg and yung excessive convexity, parang akala mo, more or less similar siya, no? But the difference is, mas malala ito. Yan. So, pag sinabi nating insufficient leg, ito buo yung leg niya dito. However, dun sa part na to, dun dudugtong mo dito, yun ang kulang. So, yun yung insufficient leg na sinasabi. Unlike dito, if you would compare it, kompleto yung leg niya hanggang doon. Kulang lang siya dito, no? Dun sa face niya. Yan, okay. On this part, ayan, ang haba ng leg dito, kabila, konti. Kulang. Again, these insufficiencies, no, or unacceptable weld profiles can lead to welding failure. Next is incomplete fusion. Yan. So, kung mapapansin nyo, mukhang okay naman, diba? But if you would take a look, if you take a closer look, pagdating naman sa root, sa penetration, yan, wala siyang penetration, no? Kulang, incomplete fusion. Maybe, siguro, yung current natin mababa. Maraming causes yan, no? But, again, this unacceptable weld profile can lead to welding failure. No?
The most popular and most common weld used in the industry: weave weld, fillet weld, groove weld, stringer weld.
Si Angelica ba to?
Yes po.
Meron na akong mga ilang katanungan, no? Pakisagot mo lang.
Opo, sir.
Ano ang sagot mo sa tanong na ito, Angelica?
Fillet weld po.
Tama ang iyong kasagutan.
What type of fillet joint is shown? T. Corner, edge, butt.
Ano ang sagot mo sa tanong na ito, Angelica?
T po, sir.
Tama ang iyong kasagutan.
What type of fillet joint is shown? Edge, lap, corner, T.
Ano ang sagot mo sa tanong na ito, Angelica?
Lap po, sir.
Tama ang iyong kasagutan.
What type of fillet joint is shown? Edge, lap, corner, T.
Ano ang sagot mo sa tanong na ito, Angelica?
Quarter po.
Tama ang iyong kasagutan.
What is part A in the figure shown? Weld toe, weld throat, weld leg, fusion face.
Russell, meron lang ako mga ilang katanungan, ano?
Ano ang sagot mo sa tanong na ito, Russell?
Weld leg ba?
Tama ang iyong kasagutan.
What is part B in the figure shown? Weld leg, effective throat, weld face, weld toe.
Ano ang sagot mo sa tanong na ito, Russell?
Weld to. Weld to.
Tama ang iyong kasagutan.
What is part C in the figure shown? Weld face, effective throat, weld leg, weld root.
Ano ang sagot mo sa tanong na ito, Russell?
Weld face po, sir.
Tama ang iyong kasagutan.
What is part E in the figure shown? Weld root, weld face, weld leg, weld toe.
Ano ang sagot mo sa tanong na ito, Russell?
Weld root po, sir.
Tama ang iyong kasagutan.
What is part G in the figure shown? Weld face, weld root, effective throat, actual throat.
Ano ang sagot mo sa tanong na ito, Russell?
Actual truth po.
Tama ang iyong kasagutan.
What unacceptable weld profile does the figure show? overlap, insufficient leg, excessive undercut, insufficient throat.
Ano ang sagot mo sa tanong na ito, Russell?
Ano po? Excessive undercut.
Tama ang iyong kasagutan. Maraming salamat, SMAW learners, sa inyong pakikisa sa ating quiz. Hanggang sa muli. Well done. Okay. Performance task. Single pass fillet weld in flat position or 1F. So if you've reached this stage, it means that you've already mastered the theory in welding single pass fillet weld in flat position. So it's time to put the theory into test or into skills. Yeah. So our objective is to weld a single pass fillet weld in flat position. Well, the bead should not exceed the required size and of equal leg lengths. Profile not concave nor convex, with fine ripples and welded plates perpendicular to each other. Okay. So the materials that we will be using are two pieces of mild steel plates, 5 mm by 50 mm by 100 mm. 4 pieces or more if you have, if it's available, a 2.5 mm or a 3.2 mm 6013 or 6011 or 7018 welding rod, welding electrodes, whichever is available in your in your homes or in your house. No? The tools and the equipment, of course, you will be needing an AC or a DC welding machine with its accessories, of course, the welding cables, the ground and the electrode cables, a chipping hammer, a steel brush, and the welding gloves and the welding mask, to protect yourself. Okay. That ends our video lesson for today. I hope you learned something. Don't forget to like and subscribe. Thank you for watching. Keep safe. God bless. See you on the next video.